Alrighty, so our job now is we're going to flip-flop back and forth between the textbook and these extra appendix lessons because there are some things that Minnesota expects a seventh grader to learn that is not in your textbook. So here we go. Make sure you absolutely have your calculator, and you should have the packet in front of you that's labeled A10. Okay. We're going to start talking about surface area. So we're still doing area, all right? But this is like when you wrap the outside of something. And we need to basically take all of the shapes that are on the outside, calculate the area, and get a grand total. So when we talk about a cylinder, okay, we have to kind of break it apart and unfold it to make a net and see what it is made up of or comprised of. So take a look at this first activity. It says a cylinder actually has three surfaces. You have the top and the bottom. These are bases. And then you have the side, the lateral side. And so the side, if you can imagine like a soup can or something, and you take that label off and unwrap it, you end up with a rectangle. And this rectangle, if we go back to when you were thinking way, way back when, a rectangle area is length times width, okay, or base times height. But this particular rectangle wraps around this circular top and bottom base. So take a look at this thing, okay? So when I talk about how tall it is, you can think of this as a height. But when we talk about this portion here, this rectangle is made by this unrolling this surface, and this is actually the same length as once around the circle, which is the circumference. And remember what we said is that circumference is pi times diameter, okay? Cool. So when I have that, that gives me this part. And then here, where I have my two circular sections, which is the top and the bottom, these are the bases. And each of these is a circle that has a pi r squared. So this open spot here is the radius. This is the radius. And each one of these areas is pi times r times r. Sometimes I like to write it that way, so that you don't confuse r squared with doubling it, okay? So here they're saying, all right, so the area of each circular base is going to be pi times the radius squared, okay? Or in other words, pi r squared. The lateral surface is the base times the height, which we already said that length or the base is pi times diameter, and then the height. So pi times diameter times height. So if we're thinking about coming up with some kind of way to have a formula here, you're going to say, well, I've got two bases. That's the top and the bottom circles. So 2 times pi r squared or pi rr. And then that rectangular area is the circumference of the circle, pi times d, times the height. Okay? And there you go. I frankly am going to let you just leave it like this. I think 2 pi r squared or 2 pi rr, and then plus pi times diameter times height. Okay? On your formula sheet, it's going to word it a little bit differently, and we're going to talk about that tomorrow when we kind of use that formula sheet for every situation. Okay? All right, now here it says, suppose the height of the cylinder is the same as the radius. How does this affect the formula? Well, here's what would happen. Your formula says this, 2 pi rr plus pi times diameter times the height. But if the height would be the same as r, you could just put that there, okay? Which this gets a little confusing because they're kind of getting at, hey, the diameter is the same as 2 r's, and then you'd basically have 2 pi rr, 2 pi rr. I think that's a little confusing. Just leave it like that, okay, for now. And as we do more and more of these, then the light bulb might come on and it'll all make sense. All right, turn the page over. So let's do a few of these. All right, here's a radius. Okay, here's your height. In addition, and like I said, I don't like the way they write the formula because I think it's confusing. So I want you to scribble this out, and I want you to write 2 pi rr plus pi times diameter times height. Okay. And now basically what you're going to do is do a whole lot of calculator work because we're going to use the approximation for pi of 3.14. Our radius is a decimal, blah, 2.5. If you have the radius, you can give me the diameter because you could just double that and that'll give you 5. So you're going to go 2 times 3.14 times the radius times the radius again. Just this part of it are your top and bottom circles. Okay, so this and this. That's what 2 times pi times radius, because pi rr is 1 circle, 2 pi rr is 2 circles. Then you have to add onto all of that the rectangular side piece, the wrapper or the label that goes around. That ends up being pi times the diameter, which is 5, times how high it is, 9.5. Oh my goodness grossness. That is a whole lot of decimal work there, huh? So you can say, thank you, guy that invented the calculator, because this is all the math. And you'll notice they're doing the same thing here with you. They put the squiggly equals approximately because we are approximating with 3.14. Crank it all out and then round it as the end. And they just say, I don't even know if they told you what to round it to, but it ends up giving you this total, 188 4/10. We're still in square inches because even though it's a three-dimensional object, we're just unrolling all of the areas and laying them flat. Okay, so do so. Write a formula for the outside area of an open cylindrical container, such as a can with its lid removed. Okay, so that means, here's what this means. You have a can, but it doesn't have a top lid, it only has the bottom. So that means you have one circle, one base, and then you have the wrapper or the label. The circle is pi r squared, or pi times r times r. The label is the circumference, pi times diameter, times the height. Since this was open, you don't have that second one. That's why we don't have the 2 there. All right? Cool. Now, here's what I want you to do. They're giving you some certain examples here. There's only 5 of them. 1, 2, 3, 4, 5. You may choose to draw a picture on the rest of these. Please do so. And then what I want you to do is take a look at the board in front and check for which IXL corresponds with these. Good luck, and may the force be with you.